Hello students, welcome to Board Maths Made Easy. In this video, we are going to learn about the polynomials. So a polynomial function p of x can be of 0 degree or more higher values. So how to know that? First of all, what is a polynomial function? Any function in the format say ax square plus bx plus c can be called as a polynomial function. Here the highest power of the value, the variable, suppose in this case the variable is x, okay, this is changing, a, b, c, these are all cofactors and their value is always constant, whether they are 1, 2, 3, it doesn't matter, but x can be taking different possible values. So that is the variable, and here the power of the highest non-zero coefficient x, the power of the highest power of the x whose coefficient is non-zero is called as the degree of the polynomial. So here in this case the highest power is x square and whose coefficient a is not equal to 0. If a is not equal to 0, then degree of this polynomial we can call it as degree of the polynomial is 2. If there is something ax cube plus bx square plus I am purposely omitting cx, instead I would say d. Here we don't bother about the lesser powers, we always focus only the highest power, and if its cofactor is non-zero, then degree is highest power of the x whose coefficient is non-zero. So degree in this case is 3. So is that clear? You will definitely get 1 mark question related to only this part for sure. And remember, we are calling them as polynomial functions, we are not calling them as equations. Why? An equation should be equal, it should have an equality symbol, and it should be something like equal to something else, like ax square plus bx plus c is equal to some 4 or 0 or something like that. Here we are not having any equality symbol at all in the given polynomial function. So in fact we will represent it as a y is equal to ax square plus bx plus c. Y is not actually a value, y is the representation of the particular given equation polynomial function. So the value of y varies with the input value of x. Okay, so whenever you want to find the value of a polynomial, what they are asking you to find the value of y for different values of x. That means, like say y is equal to, or generally this is called as a p of x is equal to ax square plus bx plus c. So what you will do here is you substitute, say xi will assume as 0, xi will assume as 1, 2, minus 1, minus 2, like that. So this way you can find the value of a polynomial at any given value x. Okay, so this concept will be useful when we go into the next steps. And in this case, suppose if the value of, let us assume if a is equal to 0, then this will be in the format 0x square plus bx plus c. Here this term becomes 0, so the power of x square, when it is multiplied with 0, it gives a total 0. That means it is independent of this power when the coefficient is 0. So the degree of this equation will be, as this equation be as this function becomes bx plus c alone, the degree of this particular polynomial is only 1. Why? Because x is having only power 1. Is that clear? So no matter what is the power of a variable, but if it's a the coefficient, you can say that, okay, the coefficient of this particular x square or x, okay, the highest power is 0, then we should be very careful that we will take only the highest power whose multiplication factor is non-zero. Okay, so if the coefficients are anywhere 0, we don't consider that as a for the degree, if it even though its power is highest. The next important concept we are going to study is zeros of a polynomial. Zeros of a polynomial. See, we are in this particular video, we are not studying everything, just concepts touch. Zeros of a polynomial, that means the value. So if a polynomial equation is given, say px of p of x, we can represent a polynomial as p of x as 2x minus 4. So this is the given equation. So the value at the values of x for which p of x becomes 0 is called zeros of a polynomial. Okay, the value for which p of x becomes 0. Here I am not saying x, I am saying p of x becomes 0. That is called a 0 of the polynomial. So here in this given equation we can simply say that if I take x is equal to 2, p of x at x is equal to 2, what will happen? P of x is equal to 2 into 2 minus 4, that means 0. So x is equal to 0, x is equal to 2 gives 0 of this polynomial equation. So if they ask you find the 0 of a polynomial, you need to find p of x is equal to 0 for what values of x this particular equation, this particular function becomes 0. Those values are called as zeros of polynomial. There is a simple and easiest way to remember this. A polynomial of degree 1, okay, here we said, right, the highest power whose coefficient is non-zero. So here 2 power x value, if I put 1, this is becoming 0. Remember, a linear polynomial, that means a polynomial with a degree 1 can have only one possible 0 of the polynomial. Maximum possible values is equivalent to maximum possible. I am not saying it must be possible, I am saying maximum possible is equivalent to degree of polynomial. If there is a second degree polynomial, the maximum values at which the polynomial can be 0 is, at the maximum you can get only 2 values, can have only maximum of 2 zeros of polynomial. What does it mean? Polynomial. Let us say there is a polynomial equation x square minus 5x plus 6. This is given as a p of x, or you can simply say as a y. So if you see here, if I think we can multiply, factorize it like x minus 2 into x minus 3. That means at x is equal to 2, this equation becomes 0. Why? If I consider at x is equal to 2, what it will become? 2 square minus 5 into 2, 10 plus 6, that is 4 minus 10 plus 6, 10 minus 10, 0. Similarly at x is equal to 3, if you substitute in the polynomial equation, what it will become? 3 square minus 5 into 3 plus 6, that is 9 minus 15 plus 6. 9 plus 6 is 15. 15 minus 15 is equal to 0. So these are the two zeros of this given polynomial. So if you remember here, the degree of this particular polynomial is only 2, and there are certain possibilities where a root can be repeated. These are all called roots. Where it becoming the polynomial 0 is called as root or factor. So x is equal to 2 and 3 are zeros of the polynomial, or simply roots. Roots is commonly used in the equations, but here also we can say not a problem. Okay, so I hope to this point we are clear. And there may be certain like say x square minus 2x plus 1 is my polynomial. Okay, this is my p of x. So this particular polynomial, how can I write it as, is equal to x minus 1 whole square, correct? This is a square plus minus a square minus 2ab 2x plus b square. Okay, so in this case x at x is equal to 1, the entire equation becomes 1 minus 2 plus 1 is equal to 0. So the roots are repeated here. So here the roots are repeated. That means there are no two different roots where this polynomial become 0. So this is one important term we should remember. This is a repeated root polynomial. Also, if there is any such equation where it is not possible to get any such values where the given equation, the given polynomial can become 0. So such polynomials are called as polynomial having no real zeros. Is that clear? Okay, I will show you such example. Let me take p of x is equal to x square plus say 9. So for any value of x, when you are doing square, what it will become? Positive only. A positive value plus positive value, can it ever become 0? So this it can never become 0. So this kind of particular polynomial equations are called no zero polynomials. Is that clear? Or we can say that polynomial has no real zeros. It is possible, like in the next higher classes you will see the complex numbers, where you can say this as a where I mean it is just only for your initial understanding. No need to this is not going to be part of your syllabus, but for you, is there any possibilities where a particular positive number whose square can become negative? Yes, that is called as complex numbers. So x, if you put it as a 3i, what is this I? Don't worry, I stands for just, you can say, imaginary number. So when x square is equal to what, it will become 3i whole square. Okay, what does it become? 9i square. Usually I square is equivalent to minus 1. I square is equivalent to minus 1 or equal to minus 1. So in this case what it will become? 9 into minus 1 becomes minus 9. So then see, these are numbers which are imaginary numbers, or simply we call it as, but otherwise they are called as a complex numbers. Okay, so there we will have a real part and imaginary part. This is actually only imaginary part. So any number which is having only I and whose square I square becomes minus 1, such numbers can become, even though if you are squaring it, they ultimately become negative numbers. But we are not going to deal with this particular complex number system in our 10th class. Okay, so we are going to limit ourselves to the real number systems, because we studied only real numbers in the previous chapter, correct? Okay, so here we have given a polynomial, and then we try to find the degree of the polynomial, and the maximum values where the given polynomial can be 0 is the highest degree possible. And if there is a cubical equation, I can tell you one cubical equation, like say right here, x cube minus 6x square plus 11x minus 6. This is my p of x. What is p of x? Polynomial of x. Remember, here we are constantly talking a polynomial only in x. In general, in 10th grade and these lower grades, the polynomials will be always in a single variable. Whether you call it as x, y, or t, or whatever you make it. Here instead of saying x cube, I would say z cube. Okay, then p of z is equal to z cube minus 6 z square plus 11z minus 6. So here we are dealing always with only single variable polynomials in a lower class. Polynomial stands for poly means multiple names, polynomials means terms, multiple terms. So is it always a single variable polynomial? Need not be, but those things we will see it in the higher grades. Here we don't want to confuse ourselves with other class content. Okay, so a polynomial means multiple terms. So here this is single term, this is another term, this is another term, this is another term. So multiple terms will make it a polynomial, and usually the variable in all the polynomials will be single variable, like x, y, or z, whatever it is, only one variable, not like x cube minus 6y square. No. Okay, so here if you take this another example I'm taking, okay, from this example, highest degree is the power of highest power is x cube, okay, 3, and whose coefficient is 0 no, so 1. That means the highest degree of non-zero coefficient is the highest power of non-zero coefficient of x is 3. So this is the degree of the polynomial. 3 is the degree of the polynomial. And can my polynomial be having negative powers, like x power minus 2 or 1 by x square minus 1 by x plus 7? So this I can rewrite in general x power minus 2 minus x power minus 1 plus 7. Can this be called as a polynomial? Never. You cannot have a polynomial with negative powers. Negative powers are never allowed. Can it be a partial, like say 1 by x square minus x plus 7? So in this case I can rewrite it as a x power minus 2 minus x plus 7. So here highest degree is 1, not minus 2. Can I mark this degree of this particular polynomial as a 1? No. Okay, because a polynomial equation can have only positive powers. And even if I say 2 root x minus 4, this is my polynomial. So here 2x power half minus 4 is the polynomial. As I said earlier, a polynomial can have only 0 or positive integers as the powers. So here this is neither 0 nor positive integer. Remember, it is not a positive integer, it is some kind of fraction, correct? So this is not a polynomial. You will get this kind of questions also in generally 1 mark region. Okay, so a polynomial can be always positive powers. It can have only positive powers. It cannot be a mixed case. Remember that. Similarly, even if part of the equation is having positive integers and another one is having a negative, this is invalid polynomial. Similarly here, we cannot have a fraction as power in the polynomial. Okay, the next point is a polynomial. Let us say this is my p of x is equal to 5. Where is x in this particular polynomial? Nowhere I see any kind of x. I don't see anywhere variable x. Yes, it is there. How? This is a constant polynomial which doesn't have any kind of power of x. X power is always 0. That's the reason x anything to the power 0 is 1. So 5 into 1 is 5. So this is a constant polynomial. So a constant polynomial, it will, if you write a equation, okay, so it will be a constant. It will be just a value like that continuously. Okay, x is equal to whatever be the change in sorry, not this one. You say whatever be the value of x, the value of y will be always 5. Y value is here, right? This is x coordinate, this is y coordinate. So p of x is nothing but what we said, y. Y is always 5. Whether you go x is equal to 100, 200, wherever you go, the value of y will be always same. Okay, that means this is the same graph, but x is equal to say 0, my y value is 5. So this is 5. And x is equal to 5, again y is 5. X is equal to 10, again y is equal to 5. So this is a constant graph like this, irrespective of the value of the x. X may be increasing, x may be decreasing. Irrespective of that, or x is equal to 0, in any case the value of y remains steady, 5. So this is called as a constant polynomial. So with this particular example, what we try to shift is from earlier equation kind of format, like function kind of format, which is written in a x terms like that, we came to a graphical method. So any polynomial equation can be represented in a graphical method. Okay, so there is a relationship like that. Suppose if you take p of x is equal to give me a second, I will try to find out a best equation which we can say. We have done this already, 2x minus 4. Okay, so how can I represent it in a graphical method? There are two methods. You have to find a zeros of a polynomial, or polynomial you can represent it in either this kind of format, like 1 by x, like this. You can say either this way, a functional format, where you can solve using the factorization. This, okay, we didn't solve this, we will solve it anyway. So here, this how we can write, can we solve this? How? If I put x is equal to 0, 0 minus 0 plus 0, 0 minus 6. So for x is equal to 0, this equation, this particular polynomial is not giving 0. Remember, zeros of polynomial means the given value should make the entire polynomial function to give the value 0. Then only that particular value will be called as a 0 of polynomial. So if I take x is equal to 1, 1 minus 6 plus 11. 1 minus 6 is minus 5, plus 11 is plus, that is 6, minus 6, that means 0. So at x is equal to 1, this particular polynomial is becoming 0. So x is equal to 1, or x minus 1 is the factor of this particular equation. If I do that x minus 1, the remaining equation will become, okay, I am writing it a bit straightforward, because I know it, I can make it as a, so if you divide x minus 1, this given equation, you will get the remainder as x square minus 5x plus 6. Okay, so for x square minus 5x plus 6, I can clearly see x minus 2 into x minus 3 are factors. That means this I can say x minus 1 into this, I can factorize as x minus 2 and x minus 3. That means at x is equal to 1, or x is equal to 2, or x is equal to 3, this particular polynomial value becomes 0. See, if you substitute 2 also, 2 cube is 8 minus 24 minus 16 plus 22, that is minus 16 plus 22 is 6 minus 6 0. So the zeros of this particular polynomial are 1 comma 2 comma 3. Even you can try substituting the 3 in the given equation, you will get the 0. So this is a normal like factorization method. There is another method called as a graphical method, something like this. The given equation, you should write it as a like this. Okay, but here this is a constant polynomial, but in the p of x is equal to 2x minus 4, how you can write? First you take the graph, substitute x is equal to 0. What will be the value of y? Minus 4. When x is equal to 0, y value is becoming minus 4. Okay, I'm just roughly putting the values. Okay, so when x is equal to 0, this is y value is minus 4. When x is equal to 1, this is 2 minus 4, it becomes minus 2. When x is equal to 1, this particular point is here. When x is equal to 2, this particular value becomes 2 into 2 minus 4, like this. 2 into 2 minus 4 means 0. 0 means here. When y is 0, where y is 0? On the x-axis. So if I draw a graph connecting all these dots, the graph will be something similar to this. So at how many values of x for x the value of polynomial is getting 0? Okay, only when x is equal to 2. When x is equal to 2, okay, here I will say x is equal to 2, x is equal to 1, the entire y value becoming 0. The y is what? Y is equal to p of x is becoming 0 only when x is equal to 2. Is that clear? That means the number of values for which the number of values of x for which the y value becomes 0 is called the zeros of the polynomial. So if there are two values of x for which let's say x square minus 4 is another polynomial. If I write this x square minus 4, the graph will be how it looks like. I try to draw that particular graph. When x is equal to 0, the equation is minus 4. Correct? X is equal to 0. P of y is, let us say y is equal to x square minus 4. Y is nothing but p of x is equal to x square minus 4. When y is equal to, when x is equal to 0, here what is the y value? Minus 4. Minus 4 means somewhere here. When x is equal to 2, 2 square minus 4 is equal to 0. That means y value becomes 0 when x is equal to 2. If I take x is equal to minus 2, that means x is equal to minus 2. Minus 2 square minus 4, minus 2 whole square is 0, nothing but 4 minus 4, 0. So if you try to take in between some 1 etc., if you try to draw the graph of this particular polynomial, it will be something like a U shape. Okay, so this is the x-axis, this is the y-axis. So for how many values of x y is becoming 0 here and here, right? When x is equal to 2 or when x is equal to minus 2, y value is becoming 0. That means the number of values for which the given polynomial is becoming 0 is 2. So the number of zeros are 2. What are they? 2 and x is equal to 2 and x is equal to minus 2, or you can write minus 2 and 2. That means this is how you can find a given equation, how many locations we are having a 0 of y value. If a given graph, something I will try to give some dummy graphs. Okay, don't worry about what exactly the equations and all. You just try to understand how to say how many zeros for a given equation. Suppose this is a x-axis as usual, y-axis. A graph is given like this. What is that graph? Don't worry. For how many values of x, this y is becoming 0. Y is never 0. Y is something here. It may be 1 or half or something, but not 0. So for none of the values the y is becoming 0. That means this particular, if there is some equation for this particular graph, this has no real zeros. Am I clear? No real zeros for this particular polynomial. Suppose there is another graph, say we are drawing only dummy graphs, don't worry, like this. So here y is 0, another point y is 0, another point y is 0, another point y is 0, and after this the graph is continuing like this, here also like this, something. So here if you look at this number of points where the value of y is 0, how many zeros of this for this particular polynomial? 4. Why? Here is 1, another 2, 3, 4. Remember, this is not x values, this is only first point of where the is it a first? No, need not be. We are just counting like 1 point, 2 point, 3 point, 4 point. Suppose there is another polynomial whose equation looks like this. If I draw the graph comes like this. So here the y value is 0 at only 1 point. Remember, y value is only 0 at 1 point. So the number of solutions for this particular graph is 1. Okay, if they are asking you to find the polynomials of zeros of the polynomials for x, then this is. See, they are not asking for x, they are asking for the zeros of the polynomial, and the polynomial is given in terms of y's. So there y value you will give some input. Okay, you give something here, something here, something here, or something here, something here. Then for what value of y, the x becomes 0. X is nowhere 0. If at all this curve coming and touching here, then x is 0. Correct? Or if a graph is continuously growing like this, some graph. Okay, some graph is like this, and this is given in terms of p of y. P of y is some y to the power something like that is given. So here the value, this is called as x is equal to p of y. So for what values of y, x is becoming 0 from here, this point to this point. Okay, in between, if there are multiple points, there may be multiple values. So for all the values of y in this range. So we will see certain concepts in the upcoming classes, not here in this grade, but in the next higher grades we will see what is the continuity, differentiability, etc. There we will learn those continuity and differentiability rules. For now we don't need to focus. I hope you understood the number of locations where in a given graph. Okay, suppose if this is the graph, okay, this is a polynomial in x, then this graph y is equal to p of x is equal to 0 at how many points? 3 points. Y is equal to 0 at 3 points, 1, 2, 3. So how many zeros of polynomials for particular polynomial? 3. This is 1, this is 2, this is 3. So how many points y is becoming 0? That many polynomials you should say. Okay, so that's all for this particular video. This may be a little lengthy compared to previous ones. In the next we will connect. Thank you. Good day.